And without further delay, I am pleased to introduce our keynote speaker, Dr. David Kanter from New York University. Dr. Kanter's research examines new governance opportunities for addressing nutrient pollution and how to manage the transition to a global food system consistent with Sustainable Development Goals. Prior to his current position, David was a postdoctoral fellow at the Earth Institute at Columbia University. He also received his BSc in Chemistry and Law from the University of Bristol and his Master's and PhD in Science, Technology, and Environment Policy from Princeton University. Dr. Kanter, on behalf of our planning committee, we'd like to welcome you to the Sustainability of Canadian Agriculture Conference, and we look forward to your presentation entitled Leveraging the Agri-Food System for a Post-Carbon World.
Thank you so much, Kim. Thank you so much to the organizers of this conference for inviting me. It's a real privilege to be with you this morning. It's actually the afternoon for me, even though I'm normally based in New York. I'm currently in the agricultural heartland known as Paris, France right now. So it is a pleasure to be with you in the afternoon here. I will start sharing my screen so you can see my slides. So hopefully you can all see that and hear me. If there is one thing that you remember from this presentation today, it is that decarbonizing the agricultural sector is absolutely essential if we're going to meet our global climate goals, and that the current policies and institutions that we have in place to try and decarbonize the agricultural sector are not up to the task. And so now is both an exciting but also daunting opportunity to think more creatively and innovatively about how we develop environmental policy in the agricultural sector, which is something that I think about a lot. See a lot in the chat, and I'm hoping it's people saying that they can see my slides. Okay, and people introducing themselves. Good. All right, so the central points for today. So decarbonizing agriculture and the broader agri-food system is essential to meeting global climate targets, especially now that the 1.5 degree target has become mainstream. For decades, the effort of the global community was to try and keep global temperatures below 2 degrees Celsius. In Paris in 2015, that became 1.5 degrees, entered the popular lexicon, and that has now become established in the Glasgow Climate Pact. And so if we are serious about meeting those incredibly ambitious targets, agriculture has to be on the menu. The current policy efforts are inadequate and ineffective for a variety of reasons that are very understandable, very realistic. There's a reason that agriculture is often the last sector to be considered in environmental policy efforts. And we'll go through why that is, or why I think that is, and what the literature has told us about that, and perhaps some ways around it. And then I would argue a new governance approach that's necessary that goes beyond the farmer. And by that, I mean that acknowledges the fact that this kind of binary relationship that policy often has between governments and farmers ignores the fact that farmers are often just one node in a much broader agri-food system, and forces and actors in that agri-food system that have a lot of influence in terms of what happens at the farm level, whether we're talking about fertilizer companies, whether we're talking about crop advisors, whether we're talking about wastewater treatment companies and supermarkets. All of these actors, not just their own activities and their own inefficiencies or waste that they produce, but also their own actions and relationships with farmers influence what farmers do when it comes to various environmental practices. And so leveraging those relationships when it comes to policy, I think, is also very important. And then finally, when we talk about, say, transitioning to a more sustainable agri-food system, that means many different things to many different people, right? So a sustainable agri-food system doesn't just mean minimizing pollution. It means providing nutritious food. It means providing healthy, well-paying, equitable work. And some of those objectives are synergistic, meaning that when you achieve one, you make it easier to achieve another, but some are in tension with one another. And often those trade-offs and synergies are resolved at a political level, and it's been quite difficult for the scientific community to visualize and communicate with stakeholders what those trade-offs are in a comprehensive way. I'll introduce a project I've been a part of that tries to start to visualize those trade-offs and help communicate those and the multiple facets of sustainable agriculture. So just want to start with kind of setting the scene here, in that agriculture, and this is not a surprise to any of you here, that agriculture, if again, we're serious about meeting these ambitious climate targets, we need to decarbonize agriculture, and as in reduce emissions significantly, right? So these are figures from a recent report from the FABLE Coalition, which is a coalition of food and agricultural researchers from across the world that look at national level trends and pathways towards sustainable agriculture. The figure on the left shows you the solid black line on the top. I don't know if you can see my cursor, but that shows you current emissions. And then if we were to follow the commitments made under the Glasgow Climate Pact and Paris Climate Agreement, and then this dashed black line is what we would arguably the pathway of emissions that we would need to follow if we are to reach this 1.5 degree target. And so that's the delta here between those two pathways. And then the figure on the right shows you the different subsectors of agriculture, whether it be crops, deforestation, livestock, peat, carbon sequestration, etc., where those emissions reductions would have to come from according to this modeling effort. But just to give you a sense of the scale of the change in emissions, the scale of the reduction in emissions that would need to occur for agriculture to be an important component of reaching the 1.5 and even 2 degree world. The issue is, and this has been the case not just in climate, but in most environmental issues, is that agriculture is often the last sector to be dealt with at a political level for several reasons, which I'll talk about. But just to give you a sense of this, this is an analysis by Climate Watch, which is an NGO and data organization that collects information on country contributions under the Paris Climate Agreement. And they analyze the different country plans. And this map shows you the countries that have specified when they're saying we're going to do a specific thing with regards to mitigating greenhouse gases from agriculture. Those are the countries in blue, and the countries that haven't specified what they're going to do in the agricultural sector, and that's in green. And so there are some notable countries that have been quite specific in terms of what they're going to do with regards to agricultural emissions, so notably China and Brazil. But other big actors, notably the US, Canada, Western Europe, India, Australia, have not outlined specific measures for how they're going to reduce emissions from agriculture. Now that is slowly changing, and one of the kind of silver linings is the wrong term, but one of the benefits of moving towards a more ambitious global climate target is that you're seeing more and more countries including agriculture in their climate plans. But as it currently stands, agriculture policymakers often very reluctantly consider agriculture because of how difficult it is to regulate emissions. So regulating farmers is hard for many reasons. First, and this is again an obvious point, but food security is an important, if not the most important national priority for many countries. Just to give you one example, in India, close to 1% of India's GDP is spent on fertilizer subsidies every year, and about 85% of their parliamentary seats represent a rural district, meaning that any meaningful attempt to try to reform those subsidies has pretty considerable structural barriers given how the institutions are set up. Just to give you one example from some of my work, where we created the first global database of nitrogen policies around the world. On the left, this pie chart here shows you the breakdown of those nitrogen policies by sector. So you might think, just looking at this, actually this is a nice reflection of the sources of nitrogen pollution. About 2/3 to sometimes 3/4, 80%, depending on what country you're in, losses come from agriculture, and the rest from waste, water, industry, other more minor sectors. But when you actually break out what policies make up these agricultural policies, what we found was that more than half are either commercial policies, i.e. policies that facilitate the commerce of fertilizers, so whether it be kind of standardizing labels or trade rules and things like that, or indeed pro-nitrogen policies, policies that stimulate and subsidize nitrogen use. And that's all for good reason. Nitrogen and nutrients in general, nitrogen and phosphorus, one of the most complex from an environmental perspective to address, because they're both essential resources in our modern agricultural system, but also these major pollutants. But as you can see, in terms of the kind of this tension or this balance between food security and environmental concerns, food security concerns tend to win out in most parts of the world. And this is at a global level, this figure. But even when you break it down into, say, OECD countries versus non-OECD countries with low levels of nitrogen or high levels of nitrogen use, though that tension exists between food security and environmental, regardless really of the level of development. So in addition to the food security concern, you have the fact that most pollution coming from agricultural sources is diffuse. It's non-point source, right? So you're spread over hundreds of millions of hectares. And that is really difficult from a policy making perspective to monitor and enforce policy. And it's much easier generally to monitor and enforce policy when it's concentrated in a small number of actors, right? And so as a result, it's been really difficult to make effective environmental policy that can be effectively monitored and enforced. This is just one example. In the Gulf of Mexico, this is the size of the bottom water area of hypoxia in the Gulf of Mexico. And I'm just going to move these things a bit. Okay, so you can see the bottom black dashed line is the goal. The limit, the aim is to limit the area of the dead zone in the Gulf of Mexico to just under 2,000 square miles or 5,000 square kilometers. And the 5-year average has been more than double that, right? And the years where there has been, where the goal has been met is not because of especially good efforts at nitrogen management or nutrient management. It's because of, if there's been years, especially of drought, for example, and less runoff to the Gulf of Mexico. But currently the dead zone in the Gulf of Mexico last year was the size of Jamaica. So the efforts to try and limit, this is obviously just one example, but even in more robust regulatory systems like the European Union, where I'm sitting right now, policies like the EU Nitrates Directive have been partially successful in some areas, but in large part, water quality nitrate pollution continues to either remain stubbornly stable or increase. And then finally, the agricultural lobby and farmers especially are a powerful political force, and legal scholars have a term for this they call agricultural exceptionalism, which sounds like a fancy term, but the way I think about it is that just there are a lot of exceptions for agriculture, and it's not just in environmental law or environmental policy, it's also in everything. I can speak more from a US perspective on this, but bankruptcy law and antitrust law and labor laws, a lot of these regulations and standards that apply in other sectors are either more loosely applied or not applied at all in agricultural sector. And this is an important factor here. This last one here is an important factor because the fact is that farmers are just one node in a vast agri-food system, right? Made up of a whole host of different actors that cross different scales from local to national to global, that are multinational companies, that are farmer cooperatives, that are certified crop advisors, right? And there are many more actors that policymakers could ultimately focus on to impact what happens at the farm level. And so I'll take this down to a nutrient perspective because that's kind of what I focus on, but it applies at a much broader scale. And I also want to quote a paper from Diana Stewart that she released last year, because I think it reflects also kind of some of the myths around some of the freedom of choice that farmers have when in fact they are very constrained in the choices that they have. So this is just, I'm quoting Diana Stewart now when she says, having interviewed hundreds of crop growers, and she's a rural sociologist at the Northern Arizona University. Having interviewed hundreds of crop growers, producers, or farmers in different regions of the US, many expressed feelings of freedom and autonomy and discussed their ability to make their own production and management decisions. However, upon learning more about the specifics of these decisions, it became clear that in many cases, farmers have relatively few options, limited information to inform their decisions, or restrictive production contracts that constrain their decisions. So while farmers are often blamed for environmental degradation, upstream and downstream actors in the food system greatly influence farmer decision-making and encourage or even direct farmers to adopt practices that are environmentally harmful. So that excerpt, that passage neatly encapsulates kind of the premise for this project that I'm working on now and that I'm presenting here, which is looking beyond the farmer at all these other actors in the agri-food system and how they ultimately influence what happens at the farm and whether we can develop new types or more innovative types of governance interventions, both public and private, that can perhaps stimulate reductions in nutrient pollution, whether that approach to environmental policy in the agricultural sector is applicable not just to nutrient pollution, but we're having discussions with pesticide scholars that work on pesticides, on antibiotics, acknowledging the fact that we need a more systemic, coherent, comprehensive approach when it comes to developing policies in this region, in this area. So in a very basic sense, the idea is that, for a lot of traditional, this is from a nitrogen perspective, but again, it can apply, I think, to many other areas of environmental governance in the agricultural sector. But traditional in agricultural nitrogen governance, you have governments essentially developing a whole host of different policy instruments targeted towards farmers with the goal of trying to change their behavior or get them to adopt new technologies with the ultimate goal of improved nitrogen management. Right? And that the idea behind a kind of new and improved governance framework is that, yes, you still have these policy instruments coming from governments, so at the same time, we're exploring also private initiatives as well, but targeted not just towards farmers, but also at all these other actors in the agri-food system who have also their own relationships, often even more influential relationships than what governments have with farmers, that can influence what happens at the farm, influence behavioral change and technology adoption in a way that actually might be more cost efficient for farmers and fairer in terms of sharing the burden of risk and the burden of regulation across more actors in the agri-food system. So to give a very specific example of this, which is kind of our first foray into this, is looking at the fertilizer industry. Now in North America, the fertilizer industry is highly concentrated. Two companies, as you can see here, Nutrien and CF Industries, control about 2/3 of this is urea and ammonia production capacity in North America. And 5 companies control over 80%. And when you actually look at their product offerings and their service offerings, almost all of them, aside from CF Industries, produce either enhanced efficiency fertilizers or fertilizer services like nutrient calculators or GPS technology that helps farmers with precision agriculture. And so while these are still niche products in many areas, apart from maybe some of Nutrien's products, there is an opportunity for fertilizer companies to gain access to a market that could be created by improved nitrogen management. And the inspiration for this paper, this study was twofold. The first was the Montreal Protocol, which is appropriate for a Canadian conference. As I'm sure many of you know, the Montreal Protocol is the international agreement signed in 1987 to protect the ozone layer, and the main culprit of ozone depletion being CFCs. That's on the left here, the spray can on the left. Now, the same DuPont, which controlled half of North American CFC production and a quarter of global CFC production, ended up coming out supportive of the Montreal Protocol, even though it would wipe out this production and consumption of CFCs, a big product of theirs. And they did that not because they suddenly saw the light and became best friends with Greenpeace, but because they also produced the alternatives that were patent protected. They went from CFCs to first HCFCs and then HFCs. This is HFC here. And so by having a global agreement, it created also a global level playing field for alternatives and created a market for those alternatives. And so I see a similar dynamic potentially with the fertilizer industry in terms of these alternatives. I should also say, as a side note, these are just pictures that I got from looking for CFCs and HFCs on eBay. I think CFCs, it's illegal to buy. I wouldn't recommend actually going through the transaction because you might get a knock on your door from law enforcement. But the idea behind also shifting towards focusing on a different actor aside from farmers is that the fertilizer industry, given that they are a smaller number of actors and given that there may actually be an economic incentive there, would be easier to implement and develop policy on. And we use the CAFE standards, which are fuel efficiency standards for cars, as a model. The beauty of those fuel efficiency standards for cars, there have been many critiques of them over the years. The idea behind fuel efficiency standards for cars is that instead of trying to regulate the driving habits of hundreds of millions of drivers, you regulate the car companies and the efficiency standards of the cars they're producing, so that you're giving drivers essentially no choice, but when they buy a new vehicle, that will almost certainly be more fuel efficient than the one that they previously had. And you're regulating a smaller number of actors, and you're also, as we've seen in the aftermath of the increase in fuel efficiency standards and the Obama administration, that it actually gave a lot of American car companies like Chrysler and others more of a competitive edge when it came to actually producing more fuel efficient cars. So we asked ourselves, what would that look like applying it to the fertilizer industry, where instead of having policies that try to incentivize adoption of technologies or create standards for best management practices for farmers, you instead impose design standards or performance standards or sales standards on fertilizer companies for these products. And it wouldn't just be about making sure that the existing generation of products are used, it would also be a way to stimulate innovation in a sector that is typically quite conservative when it comes to its R&D. Fertilizer is fertilizer is fertilizer. It's kind of like coal, right? Nitrogen is, you don't need to innovate on nitrogen. It's not like pesticides or GM crops where you constantly need to be at the frontier of research to stay ahead of pests, to stay ahead of certain environmental risks, whatever it might be. Nutrients will always be needed by plants. And so it is inherently a conservative sector. And so my own personal view on this is that in those kind of sectors, that's where the role of government becomes very important to force innovation in this typically conservative sector. Now, one country is already exploring the potential of such a policy, or this idea, namely India, where they mandated back in 2017 that all urea, which is the main nitrogen fertilizer used in India, would be coated with neem oil, all the urea that is either produced or imported into India. So instead of regulating the practices of 120 million farmers, you're regulating 30 factories that produce urea in India and the import thereof. And you're also, as a double benefit, subsidized urea was being used as an adhesive kind of illegally in India. And by coating it with this neem oil, which acts as kind of a natural nitrogen inhibitor, you're also reducing the diversion of subsidized urea to these non-agricultural sources. It was implemented recently, this policy. I haven't personally seen any independent evaluation of it. So I'd be interested if anyone knows this. I constantly am on the lookout for evaluations of how this policy is doing and whether it's actually leading to meaningful reductions in nitrogen use or nitrogen losses. So anyway, that's that. Now I want to kind of take a step back for a second. So I've introduced you this idea of like, okay, if we're going to be serious about more environmental policy and kind of more of a policy focus on the agricultural sector, we maybe need to think more creatively about how we address the agricultural sector. But I kind of want to ask even a question now that's even a bit of a step back from that. This is a figure that I'm sure many of you know, the planetary boundaries figure, one of the more iconic environmental science figures in the past 10 years. Each wedge in this pie of environmental catastrophe is a specific environmental issue. And the aim of humanity is that for each of these issues, we want to stay within the green zone here. We want to have a level of interference with each of these issues that doesn't cross any kind of dangerous tipping point, right? And there's a zone of uncertainty in the yellow. And then when you get into the red zone, that's when we're relatively sure, according to the experts that wrote this paper, we have gone into a dangerous tipping point where the risk of damage becomes increases dramatically and potentially permanently. And this paper was really what brought nitrogen and phosphorus pollution to the forefront of policymakers' minds, I think, at least at an international level. Obviously, there have been instances in more siloed cases of it being a water quality problem or an air quality problem, but dealing with it as a kind of more coherent problem, I think this was an important paper. But the question that this figure drives towards is, well, is it possible to return within a planetary boundary for nitrogen and phosphorus within, this one of the major environmental impacts of the agricultural sector? And if it is it possible to do so within the same system of production that we have today, right? Is the same system that created many of the agricultural pollution problems that we face today the best one to actually manage it, right? This is a system where we use massive amounts of input, whether it be fertilizer or pesticides or manure, pesticides that don't, and producing crops that most of which don't end up going to feed people, right? We produce massive amounts of manure that mostly end up in lagoons and polluting the air and water around us. And so making these systems marginally more efficient probably doesn't meet the scale of the challenge, right? As much as I agree with the spirit, for example, of the 4 R's, it's not clear to me that approach alone is sufficient to meeting the scale of the challenge. And let me be clear, this system that we've currently created for ourselves has had major benefits. The industrialization of agriculture, which obviously began in the 20th century and took root globally, really with the advent of cheap inputs and the green revolution, for example, and crop varieties that could take advantage of these newly available inputs, has had huge benefits, and not just in terms of feeding the world. It's also had massive, perhaps paradoxically, climate benefits in the sense of intensification of agriculture has, according to several studies, avoided a significant amount of agricultural expansion, right? And one paper suggesting that 16 years worth of current emissions globally have been avoided thanks to the intensification of agriculture, i.e. if we hadn't had these industrial inputs, these synthetic inputs, we would have had to expand more into forested areas and release all that carbon stored in those natural ecosystems to the atmosphere. Several of you maybe have seen this figure too, but I think it also encapsulates kind of both the benefit, all the complexities, or not all of them, but some of the major complexities of our current agricultural system. And so I'll just go, this looks like a bit of a spaghetti diagram. Let me quickly go through it because I think it's quite powerful. This solid black line here is just global population growth over the 20th century, so from 1900 to just past 2000, and it would be billions here, reaching close to 7 billion. This dashed red line here is what population would have been without the Haber-Bosch process, without the industrial synthesis of ammonia, in the sense that being that this is roughly the amount of people we would have been able to feed had we not developed the ability to produce synthetic ammonia, right? Another way to frame that is this dashed black line here. This is the proportion of the world's population. And here you can see that now we're using the metrics on this y-axis here. The proportion of the world's population fed with food grown using Haber-Bosch nitrogen. So close to half of the world's population today is fed with food grown using Haber-Bosch nitrogen. And you can see that manifested here also in the blue line in terms of average fertilizer input per hectare globally, which has increased dramatically since the Green Revolution. The little dip here is the fall of the Soviet Union, but what this doesn't capture is obviously the massive rise and industrialization of the Chinese agricultural sector and the Indian agricultural sector. But trust me, this average keeps going up. And then meat production per capita here, which also is obviously increasing as we bring more and more people out of poverty. That tends to be correlated with an increase in animal protein consumption, with some obvious exceptions, notably in India. So is there progress that we can make in the current system to try and reduce emissions and reduce losses of various pollutants? Yes, of course, right? So we see this again from a nitrogen use efficiency perspective, that generally when you look at the trend of development and use of nitrogen, and this is nitrogen use efficiency on the y-axis and income level on the x-axis here. And so you see initially as a country's income increases, as their GDP increases, and you get increased access to input and an industrialization of the agricultural sector, you generally see a pretty precipitous fall in nitrogen use efficiency because there is more nitrogen being applied, less of it being taken up by the crop, even though there are yield increases. And then as concerns around environmental pollution, it increases, certain tipping points are met with regards to basic needs, then concerns around the environment start to increase, you start to see efforts to increase nitrogen use efficiency. But there is a hypothetical limit. I mean, there's a hypothetical limit, and then there's also actually a real limit in the sense of what can actually be done on real fields and not just on test fields. And you know, the equivalent for me, the way I think about it, or one way to think about it, is kind of in the climate space. There's some analogous challenges with our energy system, right? And we're seeing these debates now. There was just an announcement yesterday by certain philanthropies of increased focus on climate tech, with a big focus on carbon capture technology, right? I.e., how do we make our current energy production systems, like our coal plants, our natural gas plants, our oil production, cleaner, right? By storing a lot of the carbon that they would otherwise emit into the ground, or growing more trees, right? And here you're essentially trying to keep the current energy system in place with some changes to it, right? And either by capturing the carbon before it reaches the atmosphere, or increasing the capture of carbon by reforestation. But then there are others that will say in the debate on our transition to energy system that just trying to kind of keep the current entrenched interest in our energy system happy is not the way to go, and that if we're serious about a transition to meeting 1.5 degree target, we often need to be serious about a transformation of our energy system towards renewable energies, potentially some nuclear in there, though there are obviously risks associated with that. But that this raises the same question for agriculture and our agricultural system, whether we think optimizing our current system of production is sufficient to meet to make the contributions that agriculture needs to make when it comes to meeting our global climate targets, or whether we need to think more transformatively, either in terms of how we use the land, or on the demand side when it comes to consumer demand, right? And this is obviously difficult because of entrenched interest, but also on top of the fact that nitrogen is an essential resource, and also one potential adaptation strategy in the food system that's suffering the effects of climate change. It's been noted in several studies, right, that one adaptation strategy to climate stressed agricultural systems is to add more fertilizer, to have more nutrients available for the crops. So nitrogen and phosphorus are just very unique in this complicated relationship with that we have with them, as opposed to our energy system, where you could imagine a global energy system that is essentially zero carbon. There is no way you can imagine a food system that is zero nitrogen or zero phosphorus. Maybe you can imagine a food system that's zero synthetic nitrogen and phosphorus, but even there's challenges if you're thinking about organic or other things. There are obviously limitations to what can be done there as well. So, as I was mentioning, with the 4 R's, this would be, this kind of approach to say nutrient management of the right source, the right rate, the right time, the right place, is all kind of around optimizing the current system of production, making sure that the nutrients that we are using, that we're best synchronizing plant nitrogen supply and demand in the soil, and that we do so as efficiently as possible. And then there are other approaches that are perhaps more transformative to our agricultural system, which are very different from the 4 R's, whether it be, for example, so obviously dietary change is a big one. Alternative forms of meat production. I obviously have lab meat here, but you have alternative plant-based forms of meat production. You have a massive increase, if you want, in legume production and leguminous cover crops. And then you also have certain startups working on, for example, making non-leguminous crops leguminous, right? So making corn, wheat, rice, leguminous, so that they can fix a portion of the nitrogen that they need from the atmosphere. So these are all approaches that kind of go in some ways beyond the current system of production. But to do that, you also need to have new markets. You need more structural change than just what's happening at the farm level. It can't just be something that happens at the farm level. It needs to be at the whole system, the systemic level. So I think there's a crucial role for the scientific community here, right? So we as a scientific community need to get better at studying and exploring and stimulating transformative change. We need to be honest whether the current measures that are implemented in the current industrial food system, based heavily on synthetic fertilizer use, could meet nitrogen pollution goals and climate goals, and how ambitious does the current system of agricultural production let us be. And we also need to be brave, right? So I've been involved, and I'm sure many of you have, in various scientific initiatives to give one example, on scenarios, developing scenarios for agriculture, right? And typically, when you develop those new storylines and scenarios, it's also based on what the models that are going to model those scenarios, what they can do, what they are structured to model and simulate. And more often than not, those models are structured in a way to simulate the current system of production. And so trying to develop scenarios that consider more transformative change is very difficult if you're using models, because the models themselves aren't geared towards modeling transformative change. Just to give one perhaps eclectic example of that, this is measurements of ozone depletion over Antarctica back in the 60s, 70s, and 80s. And this was from the British Antarctic Survey when they first started to realize that there was an ozone hole. And when the British Antarctic Survey started measuring this and seeing this massive reduction, they did what any good scientist would do, and they wanted to verify that other organizations that were collecting data had similar results. So they went to NASA, who were also measuring ozone concentrations in the atmosphere, and they said, "Are you getting these same measurements over Antarctica?" And NASA said, "No." They said, British Antarctica, "Are you sure?" And NASA went back and checked the raw data before it had been processed through their instrument. And in fact, they did measure this reduction. The reason that their instrument, a reason that the final measurements that the final data that they were being given was not picking it up, is because they had programmed the instrument to reject ozone concentrations below a certain threshold. They just didn't think that it was just outside the range of possible values for ozone concentrations in the stratosphere. And so they weren't even, the machine wasn't programmed to deliver this kind of information. And so for me, there's an analogy where there with the models that we use and the way that we think about these problems is sometimes the tools that we have at our disposal force us into a certain way of thinking about a problem, right? And so I think we need to be cognizant of that and wary of it. I'm going to transition here to thinking the kind of last point that I wanted to mention here about managing trade-offs and synergies, in the sense that, as I mentioned at the top, if we're talking about transitioning our current agri-food system to a more sustainable one, that's a collection of multiple objectives. It's not just about minimizing pollution. There are a whole bunch of other goals, often embodied in the Sustainable Development Goals, that a transition to sustainable agriculture involves, whether it be ending poverty, whether it be gender equality, whether it be ending hunger, whether it be clean water, whether it be protecting life on land, underwater, climate action, clean energy. All of these Sustainable Development Goals are in many ways reliant, or at least in a huge part, a significant part, reliant on what we do with our agricultural system. And some of the things that we do to, say, minimize pollution have co-benefits, and some of them have trade-offs. And so one way that we've started to try and think about this is a project that I was involved in called the Sustainable Agriculture Matrix. And this was trying to give more of a quantitative foundation to this idea of what sustainable agriculture is. So in the center, you have sustainable agriculture here, and then in this first intermediate circle, the way we think about sustainability in general, sustainable development, is it has these three pillars of economic and social and environmental. And then what we want to do in this project was to say, okay, well, we want national level data and indicators for how a country is doing when in its transition towards a more sustainable agricultural system, right? And so the big challenge, there were several challenges here. The first was actually finding publicly available data at national level that covered most of the world's countries. And so we had to figure out which indicators would best reflect the social dimension, economic dimension, environmental one, and that also had data publicly available. And then, as you can see here, we have them kind of color-coded based on how well or not a country is doing. And defining what those thresholds are for different indicators was also a significant challenge. And I should say, I was just one of many participants, that we were about 10 to 20 of us over the course of 4 or 5 years building this matrix. And a mix of public health experts and sociologists and soil chemists and economists, or a range of experts here. And so this is from the paper that we published introducing this matrix, and this kind of gives you a sense of, so globally, this is overall scores of how countries are doing when it comes to a transition to sustainable agriculture. And we picked out certain countries here that have different types of scores. And so again, and I'm sorry, there's a lot going on in this graphic, so I don't expect you to take it all in here. But just to give you a sense of what we were trying to do here was to visualize the multiple objectives of sustainable agriculture. And the fact is that actually no country in the world is doing great at meeting all of those objectives, right? And different countries are at different levels of development, have got different scores, obviously, and different levels of progress. And in developing countries, you tend to see countries doing worse when it comes to on the social dimensions, when it comes to undernourishment and rural poverty. And as you increase in development and GDP per capita, usually those social metrics tend to improve, but then your environmental metrics tend to decrease. And then as you get beyond that kind of negative Kuznets curve, maybe those environmental metrics also start to increase. But as I mentioned, no country is doing ideally on all fronts. The other thing we wanted to do in this paper was to actually try and do an initial quantitative analysis of trade-offs, to look specifically at the correlations between these different indicators that we had identified, and whether there were any significant relationships between them. And so this was one way of representing it. And I think, as you can tell from this graphic, one thing that we're desperately in need of is better ways to visually represent trade-offs, right? And there are ways to do that. I was part of a review paper a few years ago that showed the different ways you could visualize trade-offs. The challenge here was that we were looking at trade-offs across multiple variables in multiple dimensions, so environmental, economic, and social. And essentially where you see blue would be the equivalent of trade-offs. They're essentially negatively correlated. So, some make pretty obvious sense, like nitrogen surplus positively concentrated. So as nitrogen surplus decreases, then obviously you get a reduction in greenhouse gas emissions. So that's a synergy, for example. And then you have some trade-offs as well. And where you see numbers is where there was a significant correlation between these different variables. And as I say, it's just levels of correlation. We didn't kind of unpick chains of causality or anything like that here. So there are essentially some weird relationships that you might not have considered, that I definitely didn't consider as you kind of go through some of these numbers. But the point is that there are, as is not surprising, a lot of relationships, both positive and negative, between the environmental, economic, and social indicators, and understanding where the trade-offs are, where the possible synergies are. And this, I should say, this specific analysis was for China. We do have data on this for a bunch of different countries. I just use China here. And obviously these look different in different countries because of the different agricultural systems, the different policies that are in place, the different institutional dynamics, and all that kind of stuff. But just to say that I think if we are going to be serious about transitioning sustainable agriculture and we want to have a valuable role for the scientific community, I think a really important one is communicating and working with stakeholders and policymakers to understand what these trade-offs and synergies are and how we can potentially maximize those synergies, take advantage where there are co-benefits, and try to minimize trade-offs, or at least create policies that acknowledge those trade-offs and try to deal with them in some way. So the takeaways, as you all know, this is not new. Decarbonizing agriculture and the broader agri-food system is essential now to meeting global climate targets. We're serious about meeting our ambitious climate goals. And the kind of current policy efforts that we have in place, particularly when it comes to agriculture, are inadequate and ineffective. This narrow focus in most countries on farmers and how to change farmer behavior ignores the fact that farmers are part of a much larger agri-food system, that they're often constrained in the choices that they can make, and that actually the the other forces and the other actors in the agri-food system have a lot of influence at what happens at the farm level, and governance, agricultural governance, environmental governance should acknowledge that and be more creative in the kind of policies it develops. So a new governance is necessary that goes beyond the farmer, and that sustainable agriculture and the transition towards it is essentially a collection of multiple objectives. And whenever you're trying any multi-objective optimization problem, you're going to have trade-offs, you're going to have synergies. And so we need to be able to understand them, we need to be able to manage them. And with that, that's the end of my presentation. Thank you so much.